Welcome back to the QST YouTube channel. Today we will be solving the term 3 week 10 chemistry quiz until question, I think it was like until the last two questions because those are chapter 8. But in this video we're gonna be mostly focusing on chapter 9, which is all about reaction rates, since this is coming in the periodic and the final. Okay, let's go. The increase in the concentration of a product per unit time is called the rate of reaction. Rate of reaction can be two things. I'll just call it RR. It can be two things. Increase in concentration or volume of product, or a decrease in concentration or volume of the reactants. Okay, number 2. Which of the following best defines chemical kinetics? Chemical kinetics is the study of reaction rates, which is, as we said last question, it is basically the change in, like, the increase of product per unit time or a decrease in concentration of reactants per unit time. Number 3. Magnesium solid reacts with nitric acid to release hydrogen gas. 5 grams of magnesium is added to 50 centimeter cube of dilute nitric acid. Which conditions produce the fastest reaction rate? Okay, for the fastest reaction rate, first of all, let's see what they're trying to ask us for, which factor. Here the powder piece is all of this is surface area. So an increase in surface area, so powder in this case, will be the most, because an increase in surface area will lead to an increase in collisions and an increase in effective collisions, which in turn leads to an increase in the rate of reaction. And then here on this column they're asking for temperature. And what would be the highest temperature? The 60 degrees Celsius. And now we found out which one's the answer. Because here the 25 degrees Celsius is not the answer, because 60 degrees Celsius is higher, and the higher the temperature, the higher the collisions, the higher the effective collisions, the higher the rate of reaction. Number 4. A catalyst increases the rate of reaction by providing a new mechanism with a lower activation energy of the forward reaction and a lower activation energy for the reverse reaction without affecting the delta H, which is the change in heat content. The heat of the reaction. Okay. A catalyst does not get consumed. A catalyst for the biology students, but for those who don't take biology, it's basically, how can I say it, a compound, let's say, which increases the rate of reaction by only changing the path, providing a new mechanism, not path, sorry, providing a new reaction mechanism, so that the activation energy decreases for both the forward and the reverse reaction. Number 5. An energy level diagram is shown below. The reaction is exothermic since the products have less energy than the reactants. Think about it like this. Exothermic, we know that energy is released, right? So exo, let me write it here. Energy is released, so energy decreases, right? And here we can see from the reactants to the products, energy decreases. But if it was endothermic, the reaction absorbs energy. So from the reactant to product, the energy will increase. Number 7. Which of the following factors increase the rate of a chemical reaction between a solid and an aqueous solution? Increasing the concentration of the aqueous solution will result to an increase in collisions, an increase in effective collisions, and which in turn ends up in an increase with the reaction rate. Increasing the temperature will increase the collisions, increase the effective collisions, increase the rate of reaction. Increasing the volume only works for a gas. Only gas. Increasing the surface area will lead to an increase in collisions, which results to an increase in effective collisions, which results to an increase in reaction rates. An addition of a catalyst, as we just said, it changes the uh, reaction mechanism, making the activation energy less for both the forward and the backward reaction, and it is regenerated at the end of the reaction. Number 7. In 3 different experiments, equal masses of excess calcium carbonate were reacted with the same volume of hydrochloric acid. In each experiment, one factor affecting the reaction rate was changed. The volume of carbon dioxide was measured every 5 seconds, and the following graph showed the results. Okay, first of all, let's start with C. C, like if it's lower than everything else, it always has to be a lower concentration in reactants. Okay, so now we know that B is lower than A. This could be due to a decrease in temperature and a decrease in surface area, or by what they say here, using lumps instead of powder. Because if we use lumps instead of powder, the surface area will decrease, which, as I said last question, I won't repeat it after this. It will decrease the uh, collisions and decrease the effective collisions. And since A is like more steep, the addition of the catalyst, which is A, would be the graph. And I already explained why a catalyst is like increases the rate of reaction. Number 8. Based on the collision theory, a decrease in temperature of a reaction decreases the rate of reaction because the number of effective collisions between particles decrease. Number 9. Based on the collision theory, a decrease in concentration of reactant decreases because the number of collisions between the particles decreases. Okay, now this will be tough. Now you guys are meant to memorize this graph. Sorry for... Oh my goodness. It can't be like this. Okay, so we have the reactants here. We have this and something like this. So here we have the reactants, right? And here we have energy, which I'll represent as H, or heat, and then under it E, which is the heat of reactants. But here, from the reactants to, let's say, activated complex, which will be AC, this is called activation energy, AE. It is the minimum amount of energy needed for the minimum amount of energy needed for reactants to start the reaction. Then we here have the products. Here we have the heat of products. And then here the change in reactant and product. Let me just do a dotted horizontal line so don't make mistakes. And then here is delta H, which is the enthalpy change. Delta H. Now knowing this graph, let's solve the question. So A, as we said, is from the reactants to the bottom. Okay. Potential energy of products, as we said, is from the products to the bottom. The activated complex is always going to be at the top. Even if it's endothermic, it's always going to be at the top. The activation energy of the forward reaction will be Y. I don't think they'll ask for anything related to the activation energy of the backward reaction, at least that I know of. But I'll just make sure and let you guys know. Enthalpy change of the reaction, as we said, is the change between reactant and product. Let's go down. Wait. Why can't I scroll down? Hello? Okay. Upon the addition of a suitable catalyst, the value of X, which is the delta H, will remain constant. Like with the catalyst, it will only change the Y in this case, or the activated energy, as we said, and it will decrease it. It won't increase it, because if we increase the Y, the rate of the reaction is becoming slower, which is not what the catalyst does. The catalyst speeds up the reaction, right? Okay, so it will decrease the activation energy, which is Y, and the reaction is exothermic because, as we said, the graph of an exothermic reaction is like this, because energy is released from reactant to product. Number 11. Which of the following does not affect the rate of a chemical reaction? Concentration of reactants affects it. If the concentration increases, the collision increases, effective collisions increase, and the rate of reaction increases. The width of a container. Look, I think, in my opinion, they should have specified, like, if the reactant was a gas, let's say, because of the reactant was a gas, right? So let's say there's an increase in the width of the container. If it's a gas, that's an increase in volume, which is a decrease in collisions and a decrease in effective collisions. But let's hope they specify, because here they said pressure in case of a gaseous reactant, okay, but here width of the container they didn't specify, so it doesn't affect. I hope what I'm saying is correct for the last sentence I just said. The surface area of contact in case of a solid, increase in surface area will result in increase in collisions, which results in an increase in effective collisions, which at the end of the day results in an increase in rate of reaction. An increase in temperature will result in an increase in collisions, an increase in effective collisions, which at the end of the day results in an increase in rate of reaction. The nature of the substances reacting, depending on the reactants. Let's say it's a noble gas reacting with, let's say, argon and hydrogen, right? Okay, argon is a noble gas, meaning it doesn't react, so it matters. Like some like chemicals react, are very reactive, meanwhile some aren't very reactive. Catalysts, as I said, they decrease the activation energy, which increases the rate of reaction. Atmospheric pressure doesn't really matter. It's only like, as I said, they didn't specify. Like here they said pressure in case of a gaseous reactant, here they didn't specify. Number 12. A student carried out the following reaction to study the speed of reaction between zinc and hydrochloric acid. Excess zinc was reacted with 50 centimeter cube of dilute hydrochloric acid. The experiment was carried out at 25 degrees Celsius. At what time does the result to be inaccurate? Look here, we go find the point that's not on the line, and we find out the time, because here they're asking 4 minutes. We just go to the x-axis and see it's at 4 minutes. How does the rate of the reaction change over the 6 minutes? Okay, so first of all, the rate of the reaction starts decreasing, because the rate of the reaction is, how can I say it, is the change in concentration or volume of products over time. So here it starts off like as a high reaction rate, then it slows down because the amount of reactants are decreasing, and then it becomes zero as we can see here. Like over here, like when the graph is straight means that the reaction is over, and that happens when there are no more reactants left. When did the reaction finish? So we go to the first time the reaction stops, which is here, and then we go down till the x-axis to where it intercepts the x-axis, and we get that it's at 10 minutes. Number 30. The graph below shows the volume of oxygen formed during the decomposition of 25 centimeter cube of hydrogen peroxide using 0.5 grams of the catalyst. The point X at 7.5 seconds is not on the graph because there is only one answer, which is the wrong reading of volume. What volume of oxygen is collected after 10 seconds? Let's say we go here to 10 seconds, we go up, we see this point, and then we go to where it intersects at the y-axis and find out that 15 centimeter cube of oxygen is collected. How long does it take to collect 19 centimeter cube of oxygen? 19 centimeter cube is here. We keep moving till it intercepts the point. Then we go down until where it intercepts the x-axis, and we find out that it's in between 10 and 20, which is 15. Okay. Isn't there more? What caused the reaction to stop? The reaction stops only when the reactants are totally consumed. Number 14. Which of the following is the most suitable method to determine the rate of reaction above? Change in volume of carbon dioxide gas with time. It is not the change in concentration of hydrochloric acid. Wait, isn't... Okay. The change in volume of carbon dioxide gas with time, because look, okay, so because we choose the change in volume of carbon dioxide with time because we normally use the products, like the change in volume of the products, right, with time. 15. When zinc reacted with excess dilute hydrochloric acid at room temperature, the total volume of hydrogen is produced was noted every 10 seconds. The results obtained are given in the graph labeled C drawn below. A leakage of gas is E because it's the lowest. Only half the zinc is used, D because it's not as low as E, but it's lower than B and C. A slightly warmer gas is used, B. This is because, like, the only case that it's A is that when there is an increase in concentration of reactants. Okay. And then A, as we said, it's only an increase in concentration of the reactant. The final volume obtained in experiment C, so here we have experiment C, right? We keep moving horizontally till we intersect the y-axis, which is at 30 centimeter cube. Number 16. Which diagrams would be suitable for studying the rate of this reaction? Look, over here, you need to memorize that for cotton wool it's always the cotton wool and the balanced While for the stopper, while when we use the stopper, it's only the stopper and the syringe. That's it. Like here, stopper and syringe match, right? And then we would know that why would we use the syringe again? By process of elimination. Why would we use it again when there is the cotton? Because if we use, okay, yeah, forget it. Just memorize that. Just memorize that. For the cotton wool, we need to use the balance, and for the stopper, we need to use the syringe. 17. The tube of manganese oxide is suspended in the flask to prevent the reaction between hydrogen peroxide and manganese oxide. The reaction starts when the cotton string is released. This is something you have to memorize. Manganese oxide acts as a catalyst in the reaction. This is also something you have to memorize. When 1 gram lumps of manganese oxide are used, the rate of the reaction decreases. Because here they said powdered. So if we use lumps, the surface area will decrease, meaning the rate of the reaction will decrease. The reaction stops when the hydrogen peroxide is completely consumed, or in general when the reactant is fully consumed. Number 18. Which of the following is true about a catalyst? It provides a new path of lower activation energy, and it reacts with the reactants to form unstable intermediate products. A catalyst speeds up reaction and it is regenerated at the end of the reaction. A catalyst does this by decreasing the activation energy for both the forward and backward reaction. Number 20. Which of the calcium carbonate CaCO3 and hydrochloric acid HCl react as shown below? Which of the following graphs shows what happened to the mass in time as calcium carbonate reacts with excess acid? Okay, so here as okay, yeah, look. So the mass of the reactants will decrease as the reaction continues. So it will start from here and it will slowly decrease until there is this horizontal line, which means that the reaction is done and there will be a little bit left, not much. Number 21. Which of the following is the threshold energy? Threshold energy is the minimum amount of energy which the reactant molecules must process for the effective collision in forming the products. Which of the following best defines the rate of reaction? The rate of the reaction is the increase in concentration of products per unit time and the decrease in concentration of reactants per unit time, which is something we explained in the first question. Which of the following statements best defines the activation energy? It is the minimum amount of energy required by reactants to go a reaction, or basically the energy needed for a reactant to become an activated complex. Number 24. Which of the following decrease the rate of reaction between a magnesium ribbon and hydrochloric acid? Increasing the concentration of hydrochloric acid won't help because that will increase the rate of reaction, but here they're asking for a decrease. Warming the acid solution will increase the rate of reaction. Increasing the pressure as well will increase the rate of reaction. Decreasing the amount of magnesium ribbon will decrease the rate of reaction, and so will a decrease in surface area. Number 25. The graph below shows the differences in rate of reaction at different conditions. Okay, a lower temperature will be B because it is less steep, and if it's less steep the rate of reaction is lower, and since there's a lower temperature there's a lower rate of reaction, which is So when temperature decreases, there will be a decrease in collisions and a decrease in effective collisions. A higher concentration will be A, because A is more steep, and more steep means the rate of the reaction is higher. A greater rate of reaction, as we said, A because it's steeper. A smaller surface area is B because it is less steep, and a lower surface area is. Wait, no, there's one more. Okay. A smaller surface area, as we said, decreases the rate of reaction, which means that the graph will be less steep, which is exactly what B is. The addition of a catalyst will increase the rate of reaction, meaning that the graph will be more steep, so it will be A. Number 26. Consider the following potential energy diagram. Let me just redraw the graph again. Reactants, heat of reactants, HR, activated complex up here, and then here wait, no, it's AC here, then here is activation energy, here is product, here is heat of product, and here, just give me a second, is the delta H, or change in heat or enthalpy. Okay, energy of reactants is A because, as we drew it here, activated complex is B, always at the top. Activation energy of the forward reaction will be the difference between the reactants and the activated complex. Enthalpy is the change in heat, which is, as we said, D, which aligns in the position of delta H. E is the energy of products, which is the difference between the product and the x-axis. There is enough. I'm sure there is one more. Hydrogen gas H2 is hydrogen H2 exposed to okay. Testing. Okay. Anyways, hydrogen gas H2 exposed to air burns simultaneously to give H2O. The delta H of this reaction is negative 286.0 per mole of H2. So, okay, now let's say in this reaction, since they said negative 286 per mole of H2, that will give us, let me just make sure, 286 times 2 is 572 for 2 moles, right? Okay, negative 572 for 2 moles, and then here they want 8 grams, which is 4 moles, so x24, and that will give us negative 1144 kilojoules per mole. $27. Okay, let me redraw it. Reactants, products, heat of products, heat of reactants. Here we have activated complex, and this line is activation energy. This, wait, let me draw the dotted line, and this is delta H. So here, as we said, we have the activation energy, which is the difference between the reactants and the activated complex. The reactants will always be first, activated complex is always at the top. The net energy released is always the difference between the reactants and products, and the products will always be at that. Number 28. There is a danger of explosion where a large amount of dry powdered combustible material is produced because it has a large surface area. When the concentration increases, the frequency of collision increase. This leads to an increase in reaction rate. Number 29. Okay, since this is chapter 8, I won't be explaining it. Talal will be explaining it today, supposedly. Inshallah, he'll post it soon. Anyways, thank you guys so much for watching this video. We wish you guys the best of luck in the periodic and the final, and goodbye.